G'day and welcome back to Reality Check, and we're on the road at Contact in the Desert in Indian Wells near Palm Springs, California. And I've got a very interesting guest today, someone I've wanted to talk to here for a very long time, Mitch Randall. Mitch is a pioneering American engineer and inventor, renowned for his inventions and advancements in passive radar technology, particularly where we're most interested in tracking unidentified anomalous or aerial phenomena. He has a Master's of Science in Electrical Engineering, a Physics Master's degree, and he has had an illustrious career building innovative scientific instruments and research radars. At the National Center for Atmospheric Research, he designed the receiver exciter for the electro-Doppler radar, Eldora, now used in weather research. He revolutionized radar with his software-defined radio receivers, now used by the National Center for Atmospheric Research, NASA, and NOAA, the National Oceanic Atmospheric Administration. The planet owes Mitch for his innovations allowing the study of tornadoes. I think this is the coolest one. Do you know those people that go around chasing tornadoes? Well, he enabled Doppler measurements from so-called incoherent magnetron radars, enabling the creation of what are called the Doppler on wheels tornado tracing trucks, the DOW trucks, which are absolutely crucial to studying severe weather. In the 1990s, he co-founded BiNet, which allowed bistatic, which is receiver, transmitter being in different places, 3D velocity measurement for global weather radars. And beyond radar, as if that's not enough, his inventor bent led to Wild Charge, a 2005 venture for wireless charging that was licensed by Duracell and became one of Time's best inventions of 2007. He's also the founder of Ascendant Artificial Intelligence, AAI, where he's the Chief Science Officer, which does AI solutions all over the world. But his most recent work focuses on what he calls Skywatch, not to be confused with Skywatcher, Skywatch, which is a passive multi-static radar network which he's been developing with the Harvard Galileo Project to detect UAP, unidentified anomalous phenomena. So the idea is that by using FM radio signals, Skywatch tracks objects up to 80 kilometres altitude and 150 kilometres range, aiming to identify anomalous kinematics. There's a lot of buzzwords in this, so pay attention. They are the measurable characteristics of an object's motion, position, velocity, acceleration, and trajectory. Mitch has a vision, which is of a citizen-powered UAP passive radar detection network. Welcome, Mitch. Paint me a word picture of your passive radar citizen network.
And that's a big question, there's a lot to that. For one thing, it is a network. The idea is that the more volume that you can scan, the more chance you have of seeing these rare events. So if you make an instrument that's in just one location, what are the chances that an event's going to come by? And by the way, this is an instrument, right? And I'm familiar with instrument design, and that radar truck you mentioned is a perfect example. At the National Center for Atmospheric Research, we have the world's most accurate and sophisticated radars for weather research. But what's the chance a tornado is going to come by that? So that's where that Dow truck came from. The idea is you got to go to the tornado. You have to get your statistics up so that your instrument has something to read, right?
So you know where to find it.
So you have to be able to get there. It doesn't matter what the accuracy of your instrument is if it never experiences this rare event, right? So we have to get that volume way up, and that's why this is a network. And the idea is that the way that we have it set up is you put, let's say, a matrix of receivers that are spaced, let's say, 30 kilometers apart. You can cover the whole nation with 10,000 of those. But you don't want to have 10,000 scientists running that. So this leads naturally to a citizen-powered network. And that leads naturally to, well, you can't have some complicated instrument that a citizen can't operate. You need some plug and play instrument.
Let's roll back a bit.
Yeah.
So a UAP is flying in the atmosphere. So you can go up to 80 kilometres. Just explain to our audience 101, radar 101. Most people will go, what the hell's passive radar?
Right.
So active radar, as I understand it, is when you're squirting out a beam or a pulse and it hits an object and it bounces back and you can see what that object looks like or where it is.
Right.
What's passive radar?
Exactly right. So, as you say, radar transmits, signal goes out, bounces off an object, comes back. So that involves a receiver to receive that echo, but also involves that transmitter. The transmitters, that's a very expensive, big part of that radar system. In fact, in our systems for weather research, it was, 6 feet wide and 6 feet tall, big box that did that transmit pulse. But there is so many FM transmitters all around the country that are already transmitting a signal. That signal's also reflecting off objects in the sky.
So when you're saying FM transmitters, you're talking about things as basic as radio transmitters.
That is exactly what I'm talking about, yes.
So you can use existing electromagnetic radiation buzzing through the air carrying radio.
Yes.
And if something's moving through that, it's disrupting that. Is that right?
Specifically...
Give me a description of how that works.
Yeah, so just take one FM transmitter that's transmitting in all directions and one object in the sky. That transmission signal hits that object and echoes back in all directions. And one of the directions is to a receiver. So you have a path from the transmitter up to the object and then down to the receiver.
And I presume if you've got more than one receiver, which I presume is your software-defined radios, that's where they fit into this.
Yep.
And software-defined radios, again, I'm sorry about having to just get you to explain all this stuff, but most of our audience has no idea. What is sorry audience, I'm not patronising you, but what is a software-defined radio?
Yeah, a regular, in the past, a radio receiver was pretty well defined, where you need a front end that receives tuned to a certain frequency, so that means the coils are a certain size, and then there's mixers, all this stuff that's very specific to that particular frequency, right? And it all comes out, gets demodulated to, let's say, a speaker or something like that. Well, nowadays, it's actually easy just to take the original signal that's coming in and just digitize it right there. So now you've digitized the RF signal, and all that stuff that you used to do with electronics, the tuning of the front end, the mixing down and the demodulation, all that stuff, that's now all just software.
Now, I've played with SDR radios, and I think they're great fun,
Yep.
and they're mind-blowing in their capabilities. So many things you can do with them. But from memory, they're about, depending on what you're buying, they're about $100 to $500. Is that right?
No, they're $30.
They're $30 these days, are they? Oh, I got ripped off. But basically, the idea is that if you've got more than one of these radios, presumably, if they're in different locations, you can triangulate whatever that object is. Is that right?
Right. A single receiver hears can figure out a delay to that object. So a delay is a lot different than knowing the position. In a regular radar, it goes out and comes back. Actually, the delay equals that distance. You can figure that out by the speed of light. But when you have it coming out of a transmitter, bouncing off and going back down, now all you know is it's on the surface of an ellipsoid. I don't know if that's helping you at all.
No, sure.
But you don't know where on that ellipsoid is. You just know that the delay was such that it's somewhere on that ellipsoid. So you actually need another receiver. The other receiver gets another delay and has its own ellipsoid, and those intersect. And when you have 4 receivers, that's when you know the exact point.
So what would it take to cover, say, the entire continent of the United States with software-defined radio receivers to be able to set up a Mitch Randall passive radar system, a Skywatch?
Yep. So with this system, it seems ideal to have about a 30-kilometer spacing. That's like 20 miles, right? 20-mile spacing on these receiver networks. So a mesh, a nationwide mesh network, 20 kilometers, it's about 10,000 units.
Just 10,000 units?
Yeah.
So 10,000 units at what's a realistic price for the kind of radio you're talking about?
We're trying to hit $500. And this is not a for-profit thing. We're basically, if we can make it for 500, we're going to sell it for 500. That's the idea.
So that's $5 million to pay for enough units to cover the States?
Yeah.
Wow. So for $5 million, you could use the existing radio bandwidth all over the continent of the United States. You'd have 10,000 receivers at 30-kilometre intervals all over the United States.
Yes, yes.
What could we do with that, Mitch?
Well, can we back up 1 second?
Sure.
So the $5 million comes from the consumers. They buy that. So, but there is there's about $5 million that goes in to build that product, because the product has to be developed.
Sure.
That's just plug and play, very simple to use, calibrated, connected to a central server that can
So there
figure
are
out all that.
algorithms probably that you
Yes.
have to write, which
Yes.
make that all work.
Yes.
Okay. But what I'm exploring is the technical capabilities.
Yeah.
Is that something totally new? Has it ever been done before?
Certainly there's passive radars out there. Normally, and passive radars, in fact, Europe looked into replacing their version of FAA with passive radars.
Really?
Yes, they're actually more reliable because the loss of one transmitter doesn't shut down the system. And they're just receive only, so they're much less complicated.
Is there radio bandwidth all over the United States, or are there holes? Are there patchy places?
There's little patches, but FM is everywhere.
Now, you know where I'm going with this. Is there radio bandwidth, say, in a little place in Nevada called Groom Lake?
Well, that is actually, can you imagine, would you receive FM there? An FM radio would work there? Maybe not. Because
Right.
I live in Colorado, and actually if you go in the mountains a little bit, you don't get.
But I
so
guess
there are definitely patches.
If there is an area where there's a hole, could you go there with just like a radio FM booster, a transmitter, and just boost a signal in the area and use that as a sort of a temporary booster?
We could, but it's sort of out of the parameters of what we're doing.
Ah, okay.
Right? So we just want to make one product, sell it to everybody, and then get what we get.
Okay, so I'm a little green alien, and I've come from Zeta Reticuli, and I'm chugging along in my hyperluminal, superluminal spacecraft, but I slow down to come into the atmosphere, and I'm presumably chugging along, just about to have a look at the nuclear establishments in different parts of the United States, like UFOs are apparently want to do. How sure are you that if that is a solid craft object, you would pick it up?
I mean, I can't read the minds of aliens.
No,
So-
but it doesn't have to be aliens. I'm just talking about a solid object.
Yeah, I mean, more than likely, we can pick up a Cessna at 75 kilometers. So if it's something that size that has a reflective surface on it, we'll see it.
Now, what's the problem with using existing active radar to detect that kind of thing? I mean, haven't we got active radars all over the continent of the United States?
Right, then the problem you're talking about is not a technical problem. That's a political problem. So we have radars all over the place that are way more sophisticated than what I'm talking about, way more accurate, and we are never going to see that data for as long as we live. That's what I think.
Yeah, I mean, it's been very hard getting data from the FAA when there are sensitive UAP sightings. Is there a possibility, though? I'm just trying to think of reasons why this might be an issue. I do know that there are things called the ITAR regulations and the International Trafficking in Arms regulations.
Yeah.
And they treat radar, with a few exemptions, as being something that is covered by potentially defence munitions products. They're protected and you have to get permission to take them out of the country. Is that an issue for this kind of radar?
Absolutely. And it's not just taking them out of the country. If your specifications fall within their parameters and you become under their jurisdiction, that means you can't even manufacture something here because somebody can buy it and then take it to another country. So it's very restrictive. And it specifically covers passive radar. So we make sure that our passive radar is outside of those specifications, and then we're okay. And basically those specifications make sure that you can't get enough accuracy that you could target it. I'm pretty sure that's what this is all about.
So what sort of accuracy can you get?
It's kind of funny because it does depend on how many receivers you get. So if you have an object, the way this space, each one can see about 150 kilometers. for normal size stuff, right? So if you have this 30-kilometer grid, you're going to have many, many receivers that see this same thing. And that you do basically a least squares fit, where you're getting the best idea of where that thing is, even though it only takes 4 to actually know the position. If you have 5, 6, 7, 8, it just makes it more and more accurate. It's a little hard to say what that is because there's geometry that gets involved, but maybe within half a mile.
Which is perfectly fine for UAPs.
Yeah, the thing that you really get is that velocity, and that is extremely accurate, actually. And when you get the velocity, and the whole idea of these kinematic tracks, it's key. There's the 5 observables you heard about before.
Yes.
One of them, for example, is no visible propulsion thing, right? Okay, well, balloons don't have visible propulsion. So, you're always, if you say, I just observed something with no visible propulsion, then some debunker will just say, well, it could be a balloon, right? If you go through the list, there's only one thing that debunkers don't have anything to say about, and that's those kinematic tracks. So it's not just random that we pick kinematic tracks. It's very specific. It's the one thing that humans can't do. So humans can't make an object go through the sky at Mach 3 and then suddenly go from west to northbound at 3 Mach 3. That just doesn't, that's not a thing.
So the way, just to make that easier to understand, the way for a balloon to be distinguished from a UAP that's perhaps anomalous is a balloon might be travelling at wind speed with the wind, but you can actually measure the velocity, position, acceleration and trajectory of an object using passive radar. And if it's going faster than a conventional prosaic object, you can actually determine that that's something else.
Right, and I mean, to me, the whole goal of this is to prove something, is to really have a case that's just incontrovertible, right? And is the way debunking works is, if humans can do it, you don't have to say that is a balloon. You just have to say, well, humans can make a thing that does that. So maybe that's what happened.
So what's motivating your interest in passive radar? Have you ever seen a UFO?
No.
So why
I'm the only one here, Ross.
I know, you're here at a UFO conference and you haven't seen a UFO?
No.
So why are you interested in the subject?
I've just always been interested in it for decades. Interested in it, and it's got that curve to it, like, oh my God, disclosure's here. Oh, I guess not. Oh my God, disclosure. It just keeps doing that.
What do you think of the level of evidence as a scientist, as somebody who's quite rigorously schooled in assessing data? What do you think of the level of evidence at the moment to suggest that there is perhaps a there?
Well, first I just want to talk about evidence, because I think science is kind of the wrong tool, right? Because science wants to have an experiment with one variable, and it's a little bit the wrong tool because you can't repeat. Right? Where's the repeatability if you see a rare event? So
your point is you can do that with passive radar.
Yeah, I mean, especially covering the entire country, there's a good chance we'd see 3 cases a month. Who knows what the number is? But in America, there's dozens of phone calls into the National UFO Reporting Center to report sightings.
See, one of the dilemmas I have, I've now become a receptacle for people who see a UFO.
Right.
And they send me these blurry phone videos.
Yep.
And no disrespect to them, they're trying their hardest.
Yep.
But I can't do anything with it.
Right.
And I've often been encouraging them to go to the different apps, like say Enigma Labs or Phenom.ai,
Yep.
that they have tracking on the app that allows different people's communications about what they've seen to be cross-referenced, which is quite useful. With this, it's got enormous power, hasn't it? You could actually have a citizen network, not only of software-defined radios receiving data on this, you could actually be putting into a computer and cross-referencing it.
Absolutely. In fact, my actual goal is Operation Skywatch, which combines a video app, just like you're talking about, with the radar. And the key here is people see anomalous things, a lot, but they don't pull out their phone. It's not a natural thing to see some weird thing then pull out your phone. However, if the radar saw something, let's say 20 miles south of you, before you're ever going to see it with your phone, and it sends you a notification that says, get your phone out and be prepared because something's coming your way. And you could run out there with your phone before it's even over the horizon and then get the recording out. We actually, with the radar, combined with those phones, you have a good chance of getting cell phone videos out of it.
Now, I can imagine one of the reasons why there might be export restrictions on even passive radar capabilities is because the United States is anxious to protect secret technology, you know, legitimate secrets, things like new aerospace technology, stealth aircraft. Is it possible that you could detect stealth aircraft, military aircraft using this technology?
Yeah, probably possible.
So isn't there a risk that if you do move towards trying to do this, the government might change the regulations and pull it out from under your feet?
That is a possibility, and I wouldn't say I welcome that, but wouldn't that be interesting? You can't look in the sky.
Yeah.
You're not allowed to look in the sky. I think that would be telling.
You were answering the question about evidence, and you never really finished answering that question. Do you want to have more time to answer it?
Yeah, I mean,
I'd asked you if you'd ever seen a UFO and what your position was on the level of evidence. What is your position?
My position is it's incontroversial because of the volume of evidence. But it comes in a different form. Normally science is looking for that one thing that explicitly proves it. Whereas I think what we have is so many sightings, and I'm really close with some people that are looking closely at historical data and other sighting data, and it's really not possible for any other hypothesis to be responsible for all that data.
So, in conclusion, what do you believe?
They're here.
Really, you do think that?
I do.
And
well, here's one thing, Ross. Commander Fravor, I implicitly trust him. I have seen him, his body language, everything he says, everything he does. You know, if I had seen a UFO, I would believe they're here. When he sees it, I believe they're here. He sees it and tells me, I believe him.
You've worked at a really high level, developing super good radars for NASA, NOAA, the National Oceanic Atmospheric Administration. We've interviewed Tim Gallaudet before, the Admiral who has spoken out, who's the former head of NOAA. He's quite upfront about the fact that he came across things in the course of his work that raised eyebrows. Did you ever see stuff in that work that you were doing that made you think, wow, there is something here?
Not from the instruments. Typical weather radar is a beam. It's like a pencil beam, they call it. And the chance that that actually would hit a UFO twice, I mean, if it hits a UFO once, it's kind of rare. I mean, I'm assuming. It'd be rare that there's a UFO there and rare for the beam to be passing through. But by the time the beam comes back again, that UFO is going to be gone.
Sure.
So on the screen, what that means is you see one anomalous dot, and that really means nothing. It could have been an airplane, could have been anything. So
have you created any bench models of your passive radar system? Have you actually practically tested it in the field yet?
Yeah, so with the Galileo Project, I developed the proof of concept. And really what I did was copy work that had been done by the Europeans for that FAA replacement radar I was talking about earlier. They spelled out exactly in a paper in 2005, here's how you make a passive radar receiver. And I just duplicated that work because, frankly, I didn't believe it. Yeah. I thought, you know, does it really work? How well does it really work? And when I saw the first results, I was flabbergasted.
Why?
Well, I'm used to, you know, radar where the volume scan, so what it does, it goes around at 20 or 30 degrees per second and then goes up in elevation to scan a volume, right? That can take 5 minutes on a normal weather radar, and that's the kind of thing I've been doing for years. This thing, on the other hand, the radio transmitters transmitting in all directions and the radio receivers receiving in all directions. So in one measurement, you see everything that's in the sky, and the next measurement comes a 15th of a second later. So just a few hundred milliseconds later or 100 milliseconds later, you get another scan. So you're seeing this, every object in the sky.
So for what we're doing,
yes,
to define UAPs, it's actually better than existing systems.
It's better. It's better. And when you go through the equations about how radar works, it's all about average power. And you have these FM transmitters are going 100,000 watts average power, whereas our radar transmitters, they transmitted 1,000,000 watts, but with such a short pulse, the average power is 1,000 watts. So we actually have 1,000 times, 100 times more power to work with.
So we've actually got a very powerful radar transmitter system that's
Yes.
not being used as a radar.
That's right.
And with a very simple solution,
That's right.
we can turn it into a radar system
Exactly.
and find aliens.
Right.
Cool.
And the real trick is to turn it into a consumer product that consumers just plug and play. And that's turning the crank. This has been invented years and years ago. We're not inventing something new. We're just packaging it into a consumer product.
So the SDRs, they're very small. They're like almost in some cases a cigarette packet.
Yep.
You just set them on the top of the fridge and plug them into the internet, and there's Bob's your uncle.
Yep, exactly.
So it's just feeding it back to presumably a database that you've got at Skywatch.
Yeah, I mean, there's a little more sophistication in there because you're doing some digital signal processing in there to get this time delay. And the antenna has a phased array, and there's all these details, engineering details, which are all something that the consumer would never have to know about. So it's a modem size thing.
Now, can I just ask you, it's kind of a tangent, but I'm really interested in this. Dave Fravor and all those other pilots, one of the explanations that was given for why we were seeing these objects off the West Coast, and again later off the East Coast with the US Navy and the US Air Force, was because a lot of these aircraft, including the surveillance aircraft, the E-2 warning aircraft, they'd gone to phased array radar.
Yeah. Yep.
And you used that phrase, phased array.
Yes.
And it was explained that a phased array radar suddenly made
Yes.
it possible to see this stuff that many people thought might have been there all the time. Can you explain to a bear with a very small brain what a phased array radar is?
Yeah, a normal antenna is, you see this kind of surface area, it's a dish, right? And that would make a beam. A phased array of radar is a whole bunch of little transmitters that are all arranged in that same profile, but they're not only able to shoot a beam that way or listen in that direction, but in this direction and that direction, because on the other side it's a digital numbers, right? And the computer can interpret it as a beam from this direction or this direction. So you can have, what you've done when you have a phased array radar is you have many antennas. So virtually, right? It's all done digitally behind the scenes. And that's the whole trick of the whole thing.
So
you know what I was talking about earlier, where you would just see one dot and then you'd have to wait for the next scan. On a phased array radar, if you see a dot, the beam just goes there. One of the beams. Wow. Right? That's why. Because if that object is doing some kind of crazy motion, that beam is going to follow that.
So with a phased array radar, as distinct from other radars like a passive radar system, from what I was reading at the time when this huge story came out about the 2004 Tic Tac object and that was being tracked with the Spy 1 radar, phased array radar from the USS Princeton, and I think in some cases from the new, they didn't have the phased array on the jets at the time, the F-18s, but they did have this sensor system on the two different boats in the carrier group. That allowed them to not just see the object, it also seems to allow, from what I was reading, an estimation of the mass of an object, the size of an object. Is that true?
They can make some assumptions. So they know, because the only thing the radar is getting is not an image, so you can't see a width or something like that. What they're receiving is an amplitude. And you can relate in some way an amplitude to a size, but it's not a perfect function, and you certainly don't get an image.
Can you do that with passive radar as well?
Yeah, you could have the same kind of loose kind of connection. Obviously, if there's a very strong return, you would make an assumption it's a bigger thing.
Because one of the things that fascinates me, Mitch, is I'm getting an incredible number of people at the moment sending me reports, and in some cases very blurry photographs, of what they say are gigantic objects.
Right.
Like huge triangles the size of city blocks. So you described earlier a shape of a Cessna aircraft, which is a very small aircraft. Is there a distinction between what you'd see on a passive radar system between, say, a Cessna aircraft and a triangular UAP the size of a city block?
Yeah, I mean, you presumably see a bigger signal.
And you could pick up that distinction with passive radar?
Yeah, I mean, the thing is you can't necessarily work backwards and make there could be a small object that has like a corner reflector, so it's very reflective. Of course, that doesn't exactly work with passive radar. But, or you could have a large object that has some kind of stealth property to it, right? So you can't reverse engineer that. But, hopefully, like I said, if you're sending out notifications, there's something over there, maybe you get people running outside and looking at it, and then you can use that data.
Well, Mitch, there's no doubt we all want a passive radar. What was the result of your prototype tests with the Harvard Galileo Project?
For me, the proof of concept, where I saw that my radar was seeing 100 airplanes in the sky at once. So it was seeing everything in a 100-mile radius, which blew me away. Even though I knew that's what it can do, but to see it actually do it is something else. So with that, I knew right away, okay, this can form a network, and this is what we should do. Because again, at the National Center for Atmospheric Research, I don't want to build a great instrument that doesn't ever see something. I want it to be spread out so that wherever it happens, we're there.
Has this been talked about amongst radar scientists as a way of building a better radar system? It sounds to me such a simple, easy solution.
Well, I mean, normally it's just a problem, and the mother of necessity is invention, right? So, did I say that the right way?
Yeah, you did.
Okay,
yeah.
Invention is the mother of, no, anyway, there you go. But the point is, this problem just begs this solution, right?
Yeah.
So I don't know that there's any other need to, the military can't really do 10,000 receivers without having 10,000 troops out there, right?
Well,
here we can just use the citizens.
Has the US military ever used passive radar?
Absolutely, yes. In fact, you can buy a passive radar. They sell them. They're companies that are normally government, military contractors that will sell their product to you, probably under ITAR, but also it's, $3 to $5 million.
But we can do it for $5 million.
Well, we can develop it for $5 million, and then each unit is $500.
Do you think people would buy a unit like that to be part of this citizen network you're talking about?
Absolutely.
I mean, I sure would.
But everybody I talk to says they want to buy one. I'm flooded with emails of people who say, I want to buy one.
There's 2,000 people at this UFO conference, I think, would buy
exactly.
one. I mean, it'd be exciting to be part of that kind of collaborative project. I know one of the criticisms that bobbed up on Reddit when this first came up was the idea that you might be gobbling up all the data and not sharing it. How important would it be for Skywatch to be transparent about the data that it gets?
We want the data actually to be open source, so that we're going to have the data come in through our server network to our servers, and then we're going to present that as a display so that all the citizens can see that in real time.
It'd be in real time.
In real time.
Because I'm just wondering
But I'm just saying, I was going to say, is that data can also be intercepted by another, another open source thing to double check that.
What do you do if you're sitting there in front of your big bank of computers and your groaning database that's sucking in hundreds of aircraft in one area at a time, and all of a sudden you get a phone call? Mr. Randall, this is the Pentagon. We don't want you to keep on looking in that particular area. That's one of ours. I mean, how much subject to control can you be with a system like that when you get too effective? Because you might see things they don't want you to see.
Yeah. Well, part of the $5 million is budgeted for the attorneys. So if we get a call like that, then I'm going to call the attorneys. And
but it's a real public liberty issue, isn't it? Because I love the anarchy of the citizenry doing something that the FAA is curtailing, which is access to radar data. Mm-hmm. But I'm just wondering if they're seeing you coming. Isn't there the risk that they might try and anticipate this and stop you from doing it?
I mean, either they know that I'm going to fail or something, or they don't know about me, but they're not contacting me. So I don't know what's going on.
Have you had any interest from government or the military?
No, not really.
Let's talk about, you cited the 5 observables, and this is important. It's probably one of my key questions. The 5 observables are the things that delineate something as an anomalous object. There's hypersonic velocity, there's instantaneous velocity going, as the Tic Tac did from 0 to 10,000 miles an hour in the blink of an eye.
Yes.
There's no visible means of propulsion. There's positive lift, perhaps anti-gravity. And it's the fifth one that I'm about to talk about that's probably the one I'm going to put a spanner in the works of passive radar for. There seems to be some capacity for the phenomenon, whatever it is, to go stealth, to evade radar. And there's been numerous times when there's been stuff that's been visible on radar, it's disappeared from the radar.
Yeah.
Is that not the big spanner in the works? If there is an intelligent, advanced being that's travelling here in advanced technology, wouldn't it have the capacity to go stealth?
My answer for that is certainly. And I wouldn't say that there's one species coming here with one kind of ship. It doesn't seem to match the data that we have. And we definitely have data that they show up on radar. So maybe, let's even say that 90% of them are stealth mode. Then we'll detect the 10%. So still, in terms of society, if society thinks it's worth $5 million to answer this question, I mean, that's a pretty low price to pay for the chance of getting a detection.
You know, one of the things that I think resonates most with me about what you're proposing is it's easy to get despondent about what people are talking about out there in that conference because there's a futility. People are saying they've seen things. They're saying, believe me, I've had these experiences. I know this happened to me. Here's my blurry photograph. And I don't want to be cruel to them, but it's next to useless most of the time, isn't it?
In terms of answering the question for everyone else. So they're certainly convinced.
Sure. But if you can get this system up and running, how sure are you that we can get good empirical data that provides good answers?
Well, I mean, for one thing, it's seeing all those airplanes. And those airplanes are telling us by their ADS-B transponder, they're telling us their exact position and velocity. So for every dot that we detect on our screen that's moving around, we can correlate it with that transponder to see if our radar is working right. So there's always these problems that they talk about in historical radar UFO cases. They say, that was anomalous propagation, that was a cloud inversion layer or something like that. They say all that stuff, but what I'm saying is, this thing is 100% calibrated 100% of the time. So as long as there's an airplane in the sky, it's being calibrated.
So as a scientist, you can be confident that if there's a solid object there that's not using alien stealth mode, you're going to see it.
That's right.
So let's apply that to something like the big mystery that we've been reporting on a lot at News Nation. Probably the biggest mystery in recent times, aviation-wise, is what the heck were these strange supposed drone objects that were flying not just over New Jersey and New York. In fact, they were flying all over the continental United States, including Edwards Air Force Base, which is quite close to here. And I've spoken to military personnel who've been seeing these objects, knowing that they were evading counter-drone technology weapons like microwave weapons or weapons that could fire a beam to bring them down. This was a big public concern. Would your system have picked that up?
I mean, it definitely has limitations, right? And one of the limitations of any radar system is low flying. So if things are close to ground, you have an issue with that.
How far off the ground could you pick it up?
I mean, it's hard to come up with a number like that because it also depends on the size of the thing and the speed. But normally what you do is you actually ignore the ground. Your system is set up to ignore stuff that's going at zero near the ground so that you don't just see all the ground coming in, right? So if the thing is going slow, and this is exactly what happened with that balloon, remember the balloon that came over, right? It was going slow enough that the filters on their radar were set to not
so
accidentally
that's why
see that.
It was blind. They didn't see it because it was just going so slowly.
That's right. Every radar has what's called a clutter filter because they think they're not interested in anything that's going zero. But in UFO land, zero is interesting. Zero is very important.
Because I was going to say, if you're going to invade America, just do it really slowly.
Yeah, exactly. Yep.
So the implications of that are, I still don't have the answer to the question though. How far off the ground in a passive radar system would those drones have to have been in New Jersey or New York for you to be able to see them and exclude them from being prosaic aircraft?
Probably 500 feet or so. I'm just going to throw out a number. It's hard to say that exactly.
So technically, if we'd had a passive radar system with, how many receivers would you need to, say, cover the entire New Jersey region, for example?
20.
So with 20 passive radar receivers set up 30 kilometres apart, we could have set up a passive radar system to answer the question whether those drones were prosaic aircraft or not. Because the reason that's significant is because at the moment, the official explanation is that we all just misidentified these craft as mysterious objects when in fact they were normal aircraft. There's a magazine or a website called Reason that's come out with a hit job today suggesting that the police didn't see what they saw, which is definitely low-flying objects that looked like aircraft but weren't, that were hovering ridiculously slowly over suburban neighbourhoods in New Jersey. And I actually spoke to a policeman this morning before we did this interview, just to double check with him. They're still seeing these objects in New Jersey.
Right.
So we could actually capture a definitive scientific answer to the explanation that the government's been giving, that these are just normal aircraft, couldn't we?
I mean, yes, and what I think is the key isn't necessarily just looking at New Jersey where there's already people looking at it. I mean, it'd be great to have those apps that we talked about that we're tracking it. It's probably the best way to handle those. But also, where are they going? Where are they coming from? And if you had this network, that's the issue. Like, you only see them where you have people looking, right? And if you had this radar, you would see exactly where they're emanating from and where they're going to.
This is really interesting because John and Jerry Tedesco, have you ever spoken to the Tedesco brothers?
Yeah, they were in the Galileo Project.
Yeah, they're great guys. And they're sitting there with their Night Watcher mobile laboratory using all sorts of cameras, including hyperspectral cameras. And we've talked to John and Jerry a lot. And they've talked to me about how these objects, whatever they were, appeared to be coming in from the sea. So with a passive radar system, you could potentially see where they're going to and where they're coming from.
Absolutely. The key about radar, too, is when they turn off their lights, we still see them. And, you know, we've heard reports where people see them and then suddenly the lights go off and they just disappear. Or they disappear, we don't know if they shot off at lightning fast speed or if they just turned their lights off because you can't see them if they don't have lights.
So Mitch, what's happening with this? It's a great idea. I watched you at Seoul. I think I listened to you from Contact in the Desert last year, was it, or the year before? You've pitched this idea around now for at least 2 or 3 years. How's it going? Are you getting any interest to get it funded?
Yeah, the funding unfortunately cannot be a crowdsource or I just jump on that and do that, right? I have to actually be out there pitching it. And the kind of investor or the donor I'm looking for is not an investor because this is not a for-profit thing. Sure. This is complete philanthropy, right? We're just trying to prove this. And the price tag, $5 million, it's also not, we can't really do the first $1 million and then do the second $1 million. We can't really break it up that way because we're just going to turn the crank on a product and get it out in 24 months. That's the plan. And we can't stop and start that whole process. So what I'm looking for is kind of a donor who's a philanthropist, and they're not that easy for me to come by. So I'm not in that circle, and I'm an engineer.
It's so frustrating because the Pentagon can't account for $27 trillion. You're looking for $5 million. Come on, a measly $5 million. It's probably a B-52 Spanner, isn't it? Really?
Exactly. Yep.
So at the moment, nothing's happening.
There's little bits of interest here and there, but I'm not claiming to be a great fundraiser. That's one of my issues.
Are there any other great Mitch Randall ideas like that you think might provide scientific solutions for the study of anomalous phenomena? Have you looked at any other ideas in the course of your work?
I'm pretty full of this idea. I think this one has got me
overflowing. This one's pretty cool. So was Galileo excited by the results that you were able to get with your proof of concept?
Not really.
Why?
Some of the Galileo members really caught on. This is really important. Some of the members said, this is what will make Galileo work. Here's the issue with Galileo is they're making a high quality instrument that's set in one place. Now that I have experience with high quality instruments stuck in one place looking for rare events. So I know that networks are, the way to do it is with this network. That's not really their philosophy to do that way. And it would be great to put a passive radar. You actually have to put a few passive radars around each instrument installation, right, in order to get the triangulation. So that's how it would be set up. But still, you're basically waiting for something to come over, a rare event to come over this small volume.
But just to clarify, when you did the Galileo proof of concept, that was where you saw within the defined area,
Yes.
200 aircraft at once.
Yes.
And you were able to place those aircraft altitude, latitude, longitude instantaneously.
No, with a single receiver, you don't really know that yet. You can map it and correlate it with an airplane using that ADS-B information, but you're just seeing a two-dimensional display that's not position, it's not a map.
But that is achievable using a full passive radar system?
Absolutely, when you have multiple receivers, then you can work that out and you can triangulate to get the exact positions and velocities.
Is part of the reason why you haven't got funding yet because people have difficulty getting their brains around the implications of this, which is actually quite amazing what you're proposing?
I really do think that people don't know, what radar is. They're not familiar with it. They don't know that this technology is from the 1930s. They don't know, they think maybe it's an experiment or whatever. And also, I'm not a Harvard professor that started a project that has, a lot of clout to get fundraising for this.
Now, while I've got you here, I spent a lot of time when I was researching an incident called the Kaikoura Lights incident in New Zealand. It was an incident that took place when I was a 16-year-old boy in 1978. And I was fascinated by it because the official explanation back then from the New Zealand Air Force for these objects that were seen from a cargo plane was that not only were there squid boat lights on the ocean that were supposedly misperceived by the pilots, there was also this idea that the radar beams that were picking up solid objects had reflected off clouds and caused a radar return. Is that true? Can clouds which are obviously they're not solid objects, can they cause a radar return?
Well, in weather research, that is what the radar return is. But for surveillance radars that are looking for aircraft, that's highly unlikely. Normally, the return from a cloud is so low. That's what I would say.
Because I know you mentioned to me before when we were off camera that Bruce Maccabee actually consulted you at one stage to talk about this because he was investigating that very idea. Is this what you guys talked about?
No, that was a different.
Oh, it was a different
That
thing.
was a video analysis.
But what do you think of that explanation then, just so I'm clear? What do you think of the explanation that's often given that the radar reflected off a cloud and that was misperceived as a solid object, as an explanation for what was picked up as a solid object on radar?
Do you know what kind of radar it was? That would help me to know.
It was just a standard air traffic control radar.
Gotcha.
Yeah.
Okay. There is definitely anomalous propagation, and that's where the atmosphere can have an inversion where there's refraction and the signal is actually going over the horizon and bouncing off something on the ground and coming back, and that's a real thing. But I mean, that has some characteristics. So you can't just throw that out and say it was anomalous propagation. Then it has to match what an anomalous propagation does.
Right. Because a plasma. This is the other thing I wanted to pick up because I've been talking to people from Hesteland in Norway, and they use radar as part of the systems that they've got to try and pick up these weird plasma sort of objects, these orbs that they see in this valley called Hesteland in Norway.
Okay.
Does a plasma trigger a radar as a solid object?
Yes. In fact, they have meteor scatter. So you can use a passive radar. They did this in the University of Washington back in the late 90s. A meteor passes over, you can use that whole ionization trail as a reflective, an echo. It will generate an echo from a transmit signal.
Sure. So Mitch, You admit they're here. Do you have any theories about what they are?
Oh, I have all sorts of theories. No, I mean, it's crazy to imagine what they were. If you really get to the point where you think aliens are here, which is where I got to a few years ago, I realized that the next step after that is, every theory you've ever heard could possibly be on the table now, because what are the limitations if they're here? So it does get a little bit crazy.
Do you find, as a scientist, and I can say a hugely respected scientist, you've got an impeccable reputation in radar science. You're one of the leading radar scientists in the world. Has it caused you grief for your credibility to talk seriously about UFOs?
I don't think I have quite that reputation. But no, it hasn't made any effect on me.
Are you surprised then when you say that as a scientist you've reached a conclusion based on evidence that there is a there, that we are not alone? Why do you think so many scientists have so much trouble accepting that?
Well, for one thing, I'm not making a scientific claim that they're here. I'm making a personal claim that they're here. And again, science is a box that people like to apply to problems. And it applies really well to certain problems, way better than other problems. And this is one of the problems where there's no repeatability, there's no way to make a controlled experiment. So this doesn't exactly fit into the model of...
But with passive radar, there is repeatability.
Yes.
It can be a controlled experiment.
Yes.
We can get an answer.
Correct.
Well, let's make it happen, Mitch.
Let's do it, Ross.
Thank you very much, Mitch Randall, for joining Reality Check.
My pleasure. Thank you very much, Ross.
And before we go, please don't forget we do our weekly question and answer, and we need your questions. So please send your questions in by email to realitycheck@newsnationnow.com. Looking forward to hearing from you.
Thank you for watching. Subscribe below and download our News Nation app right now on your phone, and you will get fact-based, unbiased news for all Americans.